All right, members. You're welcome to our to our fifth lesson of physical chemistry. And still, we are under buffer solutions, and this is a question from acidic buffers. And the question is reading that calculate the pH. You want us to calculate the pH of a solution formed by adding 15.0 cubic centimeters of 0.1 molar sodium hydroxide to 32.0 cubic centimeters of 0.1 molar propanoic acid. As you can see, this is also, this one will also constitute an acidic buffer in that the propanoic acid and then the sodium propanoate that will be formed after the reaction between these two will constitute to an acidic buffer. I want you to know that for this solution, if we are adding 15 cubic centimeters of sodium hydroxide to 32 cubic centimeters of propanoic acid, there will be an increase in volume of the solution. So we shall have a solution with an increased volume. Now, given all these and this information, we have been given Ka. It implies that given Ka, one can use the other Anderson-Ashebach equation, and then we move. We need to work knowing that pH of ours is equals to pKa plus logarithm base 10 of a salt, and our salt would be sodium propanoate, so CH3, CH2, COONA, out of the concentration of the acid, which is propanoic acid, so CH3, CH2, COOH, that is propanoic acid. Now, but we don't, we have Ka so far, we have Ka, so we can substitute here negative logarithm of Ka to get pKa, but we don't have the concentration of the salt, right? We don't have the concentration of the salt, and also for the acid, we have to work on it. Now, members, for this question, when you look at this, they added 15 cubic centimeters of 0.1 molar sodium hydroxide, meaning that we need to get moles of sodium hydroxide in that volume. Moles of sodium hydroxide in 15 cubic centimeters, it will be equaling to 15 times the concentration, which is 0.1, this one, then out of 1,000. And here the number of moles are 1.5 times 10 to the power negative 3 moles. Then further, we need to get moles. After getting moles of sodium hydroxide, we need moles of ethanoic acid, propanoic acid. So our moles of propanoic acid are going to be equaling to, we are getting moles in 32, so it will be 32 times the concentration 0.1. We shall divide this one by 1,000. So when you do this, you're going to get moles equivalent to a 3.2 times 10 exponent negative 3 moles. Now, after getting these moles, we have to write the equation to show the reaction between sodium hydroxide and the propanoic acid. So I will have my propanoic acid plus, of course, this is aqueous, plus sodium hydroxide, that is aqueous. We are going to form sodium propanoate plus, after forming sodium propanoate, it is formed alongside water. Because this is an acid and a base or an alkali, we form a salt and water only. All right. So now after forming this, you can really see that moles of sodium hydroxide and sodium and the propanoic acid are equal. So moles of propanoic acid are equal to, yeah, you have forgotten CH2. So moles of propanoic acid are equal to moles of sodium hydroxide. All right. What does it imply? Moles of propanoic acid are equal to moles of sodium hydroxide, which are equal to moles of sodium propanoate. I guess we are seeing this. So implying that moles here, I will say that moles are moles of sodium propanoate are also going to be equaling to moles of sodium hydroxide, which is equals to 1.5 times 10 to the power negative 3. Looking at the reaction ratio, moles of propanoic acid are equal to sodium propanoate, which are rather are equal to sodium hydroxide, which are also equal to sodium propanoate. So implying that moles of sodium propanoate are 1.5 exponent negative 3. After getting that, we shall look for excess moles of propanoic acid. Excess moles of propanoic acid are going to be equal to original moles minus those ones that reacted. All right. So we shall have 3.2 times 10 to the power negative 3 minus 1.5 times 10 to the power negative 3. So excess moles of propanoic acid are going to be equaling to 3.2 minus 1.5, that is 1.7 exponent negative 3 moles. Ladies and gentlemen watching me, we have to get moles of excess. Reason, the sodium hydroxide reacted with the ethanoic, the sodium hydroxide reacted with the propanoic acid to form sodium propanoate. As that reaction was taking place, you realize that the moles of ethanoic acid are equal to moles of sodium hydroxide. And moles of sodium hydroxide are 1.5. So if I want to get the excess moles of propanoic acid, I will take 3.2, the original, minus the ones which are from the mole ratio, so which is 1.5. So the excess moles of propanoic acid are 3.2 minus 1.5, which will give us this. So after getting moles which are in excess, all right, you need to know that those excess moles, if we are to state the assumption here, the assumption would be that the excess moles of we assume that the excess moles of propanoic acid and sodium propanoate, which was formed, are the ones that constitute to a buffer solution. All right. So now after getting this, let us note that. Let's note that the excess moles of propanoic acid and the sodium propanoate formed constitute a buffer. That is one of my assumptions made. Now, you realize that after getting 15 cubic centimeters and then added 32, the total volume of the solution is going to change. So we shall get total volume of the solution and the volume of the solution will be equaling to 15 plus 32, which is going to give us 47 cubic centimeters. You're going to allow me turn to another side. You're going to allow me turn to another side, or you allow me do like this. We have our 47 cubic centimeters as the total volume of the solution. All right. It means that these 47 cubic centimeters of the total solution contain these moles of the excess acid. Then we get moles in 1,000. Then also, that very volume, the 47, will be containing these moles of the salt, that is sodium propanoate. Then we also get moles in 1,000, and then we substitute in our equation. Because that volume, this volume, as I've told you, it is the volume for the total, rather it is the total volume of the solution, meaning that this 47 is the volume containing these moles of ethanoic acid, and at the same time, this is the very volume containing these moles of sodium propanoate. So we need to go, when we have known that this 1.7 is in 47. What about 1,000? We need to go knowing that this 1.5 of sodium propanoate is in 47. What about 1,000? Good. So now I'm going to say that 47 cubic centimeters of the solution contain 1.7 times 10 power negative 3 moles of propanoic acid. What about 1,000? These ones will contain 1.7 times 10 power negative 3 times 1,000 out of 47 moles of propanoic acid. So this one will give, hey, this one is moles, this one is moles, don't worry, this one is moles. So this one will give us the concentration of propanoic acid as 0.03617 moles from the calculator. You press your calculator, you get this answer. Then still 47 cubic centimeters of that very solution contain the moles of the salt, sodium propanoate, which are 1.5. We got these ones from the mole ratio, times 10 to the power negative 3 moles of sodium propanoate. If that is the case, what about 1,000? It will be containing 1.5 times 10 to the power negative 3 times 1,000 out of 47 moles. And this one will give us the concentration of sodium propanoate as, when you compute this, you're going to get 0.031915 molar. Now, we bring these concentrations into our equation of pH is equals to pKa plus logarithm to the extent of concentration of the salt, that is sodium propanoate, out of the concentration of propanoic acid. And this is going to be equaling to pKa. They gave us the Ka. So when you're given Ka, this is a negative logarithm to the extent of 1.35 times 10 to the power negative 5 plus logarithm. Now we were given this concentration. So the sodium propanoate, we have gotten it as 0.031915 out of propanoic acid, which is 0.0303617. All right, I'm concluding it from here. So this is going to be equal to, from here, negative logarithm of this. You're going to get 4.87. This one will be, we are adding logarithm of this. This will be negative because this value is lower than this. So it will be negative. When you compute, you get 0.0544. And this one gives you the answer of pH as 4.82. Therefore, the pH of this solution is 4.82. Interesting. Our followers, that is very interesting, and that is how the question is supposed to be done. Now, from here, I'm going to do you one more example about these buffers. I'm going to do you one more example, and then we see how it can be done. All right, so allow me erase this, and then I put for you one more example, and we do it together and we see. This example that is saying 10 liters. Let me call this one my part A. 10 liters of aqueous solution of trichloroethanoic acid was completely neutralized by 10 cubic centimeters of 0.01 molar sodium hydroxide. Calculate the pH of the solution. Calculate the pH of the solution. You're given Ka as 0.224 moles per decimeter cubed at 25 degrees Celsius. Let's first do that. After doing this part, I'm going to add part B of this very question. But after we have attempted this, now they are telling us that 10 liters of this aqueous solution of trichloroethanoic acid was completely neutralized by 10 cubic centimeters of 0.01 molar sodium hydroxide solution. They want us to calculate the pH. Now, ladies and gentlemen, listen. You need to know the reaction between trichloroethanoic acid. Trichloroethanoic acid. We need to know how trichloroethanoic acid reacts. So trichloroethanoic acid react with the sodium hydroxide to form trichlorosodium ethanoate. So shall form trichlorosodium ethanoate and water. Now, remember, they have told us that 10 liters of aqueous solution of trichloroethanoic acid was neutralized by 10 cubic centimeters of 0.01 molar sodium hydroxide. So we need to first get moles of sodium hydroxide. As we are given moles in 1,000 cubic centimeters, so we shall be saying that 1,000 cubic centimeters of sodium hydroxide contain 0.01 moles. What about 10? Because 10 is the reacted volume. So 10 cubic centimeters of sodium hydroxide will be containing 0.01 times 10, all right, out of 1,000 moles. And these moles are going to give, we are going to get 1.0 times 10 to the power negative 4 moles. These are moles of sodium hydroxide that reacted. On the other hand, they say that 10 liters of aqueous solution of trichloroethanoic acid. But guess what? From the equation, you can really see that the number of moles of trichloroethanoic acid are equal to the number of moles of sodium hydroxide. So allow me to say that from the equation, moles of trichloroethanoic acid are equal to trichloroethanoic acid. Those moles are equal to 1.0 times 10 to the power negative 4 moles because of the mole ratio. Now I'm going to do this number in an alternative way from how we did the other one. I want to show you that I can do this number without considering the salt, without using the equation of the Anderson. So I can as well get the concentration of the hydroxide ions, rather of the hydrogen ions from this acid, and then I get the pH. So after getting these moles, remember these moles, if 10 liters contain these moles, if I need moles of 1 liter, so I will be saying that 10 liters of trichloroethanoic acid contain 1 times 10 to the power negative 4 moles. What about 1 liter? So that I get moles per liter. Remember, it is the moles from the reaction that are in 10 liters if the mole reaction ratio is 1:1. But they told us that 10 liters was completely neutralized by the moles we shall get from 10 cubic centimeters. So 10 cubic centimeters gave us these moles. But from the reaction ratio, the moles ratio will keep the same. But those moles we've gotten are within 10 liters. How about in 1 liter? So 1 liter of trichloroethanoic acid contain 1 times 10 to the power negative 4 times 1 out of 10. This one will get us moles per liter. And you really see that this one can give us the concentration of trichloroethanoic acid, all right? As if we divide by 10, you're going to have 1.0 times 10 to the power negative 5 molar. Now, after getting these moles, remember from this equation we have written, we can get the mole reaction, or rather we can get the expression for Ka, because this is a weak acid, and we expect that when a weak acid dissociates, all right, when a weak acid dissociates, we can get a weak acid dissociation constant. So from the equation here, we shall get Ka, which is equal to, why am I saying Ka? We have a weak acid involved, all right? And this one will be equivalent to Ka, will be equivalent to the salt, concentration of a salt, trichloroethanoic sodium ethanoate, all right, times of course here, I want us to be very, 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 very keen on this expression. Now, one will ask the question, because we are not going to include some of the, stuffs like water or whatnot. So now, but you can really see, much as one can use the concentration of the I beg your pardon, because here, if we get the concentration of the acid, we have gotten the concentration of the acid, then one can easily get the pH. One can easily get the pH because we've gotten concentration of the acid, meaning that we have the concentration of the hydrogen ions, all right? We have the concentration of hydrogen ions. So this step may not be too necessary. Maybe it will be necessary in part B. Now, we shall say that our pH is equivalent to negative logarithm of cost base 10 of hydrogen ion concentration. Now, this hydrogen ion concentration is the concentration of the acid. As you know, that an acid is a substance which, when dissolved in water, all right, produces hydrogen ions as the only positively charged ions. So these moles we've gotten here are going to be considered as moles of the acid. Rather, they are moles of the acid, but an acid is the one with hydrogen ions, and therefore these moles, I'm going to use them as moles of the acid, and therefore it will be negative logarithm to base 10 of 1.0 times 10 to the power negative 5. And as you can look, when you take the logarithm of this, you're going to get your pH as 6. That is part A of the question that I'm trying to discuss. Now, part B of this question, now that one will necessitate me to first get you rid of this, then I write for you part B, we do it chap, and then we call it a lesson. Now, our part B of this question, part B of the question is saying, the solution in A, the solution of trichloroethanoic acid in A was added to a 0.1 molar sodium trichloroethanoate. Sodium trichloroethanoate to a 0.1 molar sodium trichloroethanoate. Calculate the pH of the resultant solution. Calculate the pH of the resultant solution. All right. Here, I'm going to use two alternatives. I'm going to use two alternatives. And the first alternative is for the Anderson's equation, whereby we shall say that pH is equals to pKa plus logarithm to base 10 of the concentration of a salt out of concentration of the acid. We have all the concentrations because from our part A, we got concentration of the acid, which was 1 times 10 power negative 5. And therefore, we are given also the Ka. And with the Ka, you can get pKa. So it will be negative logarithm to base 10 of the Ka value that we were given. And the Ka value was given as 0. All right. The Ka value has been given as 0.224. So plus logarithm to the base 10 of concentration of a salt. Our salt, the concentration has been given as 0.1 molar because we have sodium trichloroethanoate. So we have 0.1 molar out of the concentration of the acid, which you got as 1.0 times 10 to the power negative 5, as in from our Roman 1. So when you sum up this, you'll be getting, when you sum up this, you'll be getting a total, get the value here, get the value here. You're going to be getting a total of 4.65, 4.65 as our pH, 4.65. Alternatively, one may not need to use this equation, or maybe you forget how it is arranged. So from there, I encourage that you look at trichloroethanoic acid being a very weak acid. All right, being a very weak acid, trichloroethanoic acid, being a very weak acid, it will weakly dissociate or partially or slightly dissociate. And when it dissociates, it will form trichloroethanoate ions. And the hydrogen ions, an alternative method, so that from here we derive an expression of Ka as the concentration of the products, CCl3 minus times concentration of hydrogen ion. Everything we divide by the concentration of what is dissociating, which is the trichloroethanoic acid. Now, but we know that pH is the negative logarithm of hydrogen ion concentration. So we need to make hydrogen ion concentration the subject of this formula. And therefore, allow me to say that hydrogen ion concentration is equals to, it will be Ka, if you cross multiply here, it will be Ka times the concentration of trichloroethanoic acid divided by the concentration of trichloroethanoate ions. So it will be Ka times trichloroethanoic acid out of the concentration of the trichloroethanoate ions. And this one will be, our Ka has been given as 0.224 times trichloroethanoic acid concentration. We got it in part A as 1.0 times 10 power negative 5. Everything divided by trichloroethanoate ions, the concentration has been given as 0.1 from here. So this one will give you the concentration of hydrogen ion as 2.25 times 10 to the power negative 5 moles per decimeter cubed. So after getting this, you can easily get your pH because you have the concentration of hydrogen. So our pH is a negative logarithm base 10 of hydrogen ion concentration. And this is the same as negative logarithm to the base 10 of 2.25 times 10 to the power negative 5. So when you take the logarithm of that, you're going to get your pH still as 4.65. Our viewers, we love you so much. Don't forget to subscribe to this channel, which is Hyper and Chiwa4 Academic Channel. We love you so much. Keep subscribing, share the link, like, you comment. We shall be grateful for all your feedbacks. We love you so much. And our next lesson in the afternoon will be organic chemistry, whereby we are going to be covering the aspects of benzene, reactions of benzene. So in the afternoon, catch me up next. We are going to cover benzene and its derivatives, basically the reactions. I wish you all the best. See you next time.